You probably don't think about aggregates every day while driving, but concrete is a crucial component in Louisiana's transportation infrastructure. It is utilized in the construction and maintenance of many of the state's roads, bridges, and other structures, and creating the right concrete mixture from a variety of aggregates is a complex process. One of concrete's primary vulnerabilities is the alkali-silica reaction, ASR, which can cause alligator cracking over time, leading to costly repairs and potential safety concerns. This is also known as map cracking or pattern cracking. As a result, DOTD engineers are highly motivated to identify and implement the most efficient and effective test methods to evaluate ASR potential in its materials. In response to this ongoing need, LTRC Concrete Research Manager Zen Liu and his team recently completed a multi-year project assessing the suitability and potential adoption of an innovative test method called the Miniature Concrete Prism Test, or MCPT. First published in 2018 by the American Association of State Highway and Transportation Officials, also known as ASTO, MCPT is advantageous for both its reliability and timeliness. Prior to the development of MCPT, the two tests most commonly used by industry researchers were the Accelerated Mortar Bar Test, or AMBT, which is prone to produce false positive or false negative readings, and the Concrete Prism Test, or CPT, which yields much more reliable results, but takes 1 to 2 years to produce. MCPT, by contrast, has been shown to yield accurate results in only 56 days, which significantly accelerates the evaluation process, leading to a more efficient completion of projects.
Our research team designed and executed an extensive battery of laboratory tests over a 1-year period. We compared and contrasted the result of the MCPT with those of the MBT and the CBT, with a goal of evaluating its reliability of assessing SR potential. We chose a diverse array of 24 aggregates known to be potentially reactive, along with 2 control samples, ultimately producing a total of 96 unique mixtures for us to evaluate. We measured those samples at 7, 28, and 56 days, as long as 3, 6, 9, 12 months to evaluate its susceptibility to SR. All those tests were done in accordance with the standards outlined by ASTO and ASTM.
These tests yielded promising results overall. The MCPT and CPT methods produced an impressive 95.8% agreement rate for aggregate evaluation. Additionally, the team evaluated 33 of the mixtures for ASR mitigation strategies, revealing a 79% agreement rate between the MCPT and CPT methods. Based on these results, the researchers recommended that DOTD adopt the MCPT method to evaluate ASR reactivity for all coarse aggregates used in the state's transportation system, as well as for fine aggregates that do not exceed a 0.30% expansion rate from the AMBT method. The research team's MCPT recommendations are currently under review by Louisiana DOTD officials. In fact, these outstanding efforts were recently recognized by the Research Advisory Committee of the American Association of State Highway and Transportation Officials, as LTRC was honored with a 2025 High Value Research Award.
The MCPT test method provides Louisiana's engineers with a useful new tool to produce reliable results for the routine assessment of an aggregate's alkali-silica reactivity over a much shorter period of time. By utilizing this test, suppliers no longer have to wait 12 months or more to receive the result they need. Evaluating the source materials for concrete has historically been a costly and time-consuming process. Our team's favorable evaluation of MCPT method will save the transportation engineers significant amount of time on their projects, allowing critical infrastructure needs to be addressed more efficiently and effectively. This is a win for the state DOTs, their industry partners, and ultimately road users across Louisiana and beyond.